Hello, my name is Chad Milburn, and this is my final project for time series analysis. My application is dedicated to forecasting hotel stays and cancellations through SARIMA modeling. I have developed and deployed this application as a solo project on PythonAnywhere, where it operates as a live, interactive web tool. The primary objective of the app is to empower hotel teams to make informed operational decisions through precise time series forecasting. It anticipates future bookings to enhance staffing and supply planning while also predicting cancellations to optimize revenue with more effective oversell strategies. Additionally, it functions as an interactive SARIMA modeling sandbox, enabling users to gain insights into how different modeling choices influence forecasting performance. This application was developed using Flask as the main web framework and is deployed on PythonAnywhere for convenient access and sharing. To forecast hotel data, I utilize SARIMA models from the stats library, which effectively capture both seasonal and trend components. Additionally, I incorporated STL decomposition to visualize and interpret the underlying structure of the time series by breaking it down into its seasonal, trend, and residual components. To evaluate the performance of my forecast, I utilize scikit-learn to calculate common accuracy metrics such as root mean square error, mean absolute error, mean absolute percentage error. For residual diagnostics, I employed autocorrelation function plots to assess whether the model had adequately captured the temporal dependencies in the data. Additionally, I used Panda and NumPy to prepare time-indexed datasets, while matplotlib was utilized to create visualizations of the forecast and diagnostics charts. Let's take a look at the web application. This is the homepage of the app broken down into three main sections: data understanding, forecasting tools, and modeling evaluation. Datasets helps the user take a look at the first 100 rows of the raw data, the descriptive statistics of the full raw data set, as well as taking a look at the first 100 rows of each of the time series data after processing, makes it ready for each of the models that we'll use later in the app. From here, we can also take a look at the decomposition plots for each hotel type, as well as each time series for the hotel type. Each decomposition plot contains the observed values, the trend values, the seasonality, and the residual noise. After getting a good understanding of the data, a user can take a look at the forecasting tools. We provide a baseline forecast, which is a seasonal naive, again, for each hotel type and each of the time series for the hotel type. From the time series plot, we can also see the MAE, the RMSE, and the MAPE values for each of the different baseline models. A user can then come in and take a look at the recommended forecast, as well as plotting their own forecast to see what the results of each different argument will do within their SARIMA model. Should a user not be familiar with time series, provide some information on each of the arguments for the models. Give a simple bullet with a couple definitions to the parameters. The user can then generate a forecast as high as 60 days, and they can modify their own parameters and run their forecast and then compare their results against the recommended model. A hotelier could simply also come to a property level forecast if they just want to simply see their 14-day forecast for their hotel type, just by coming here and clicking on Generate Forecast. We provide 14 days worth of demand data, as well as 14 days worth of cancellation data. Then finally, after they've understand the data, take a look at the forecasting and kind of give some evaluation information. So each final model was selected based on a grid search or some visualization and other parameter selection. Provide the parameters, the AIC, RMSE, MAE, MAP value, the actual versus the forecasted data, as well as some residual diagnostics data for each model. In addition to the final model diagnostics, we also provide those same final models and compare those against the baseline models. In the baseline model, we have a table that gives us the SARIMA values as well as the baseline values, and a quick actual value versus predicted values for each of the time series. This concludes the live demonstration of the web app.